What if I told you that there was an element so abundant and powerful that it could meet the United States energy needs for thousands of years? The element named after the Norse god of thunder, hidden in plain sight with rock and sand. It might sound like science fiction or a long-lost Marvel plot, but it's real. It's called thorium, and many believe it's the key to safer and cleaner nuclear power for generations to come. Picture this, a nuclear reactor that can't melt down in the traditional sense, that produces a fraction of the long-lived waste of today's reactors, and runs on fuel that is as common as lead. It's not a fantasy, it was briefly demonstrated decades ago, and then abandoned, but now it's making a comeback. In this video, we're going to explore why thorium could be a game changer. So grab a seat and maybe a snack. We'll journey through the birth of nuclear power, the cutting edge designs of tomorrow, and the science of thorium. By the end, you'll understand why some see it as the holy grail of energy, and whether the hype is justified. Let's set the stage. We live in a world that relies on energy, but the way we get that energy is at a crossroads. On one hand, global demand for power keeps rising as population and technology grow. On the other hand, we're facing the harsh reality of pollution and climate change from the traditional energy sources. This is the classic energy crisis. How do we get more energy without frying the planet? Here are some eye-opening facts. As of the early 2020s, 79% of the world's energy comes from fossil fuels, coal, oil, and gas, which all emit greenhouse gases. It's no wonder that in 2023, carbon dioxide emissions hit a record 37 billion tons. We're pumping out carbon as if we had a spare atmosphere in the closet. At the same time, more people are striving for a better quality of life, which means more schools, hospitals, homes. We're going to need a lot more power, and clean power, in the coming decades. Renewable sources like wind and solar are fantastic and getting cheaper, but they have their limits. Solar and wind aren't constant, and we're still working on storage for them. That's why many experts say that we can't hit strong climate control without nuclear energy. Nuclear power today provides about 10% of the world's energy, making it the second largest source of low-carbon energy after hydropower. It's a proven way to generate lots of electricity without greenhouse emissions. The catch? Traditional nuclear power has some well-known downsides. Concerns over safety, the power of long-lived nuclear waste, and public fear. This is where thorium enters the conversation. Thorium offers tantalizing promise for some of those nuclear drawbacks. Imagine nuclear reactors that are inherently safer, that produce far less nuclear waste, and run on fuel that's more plentiful than the uranium we use now. Sounds almost too good to be true, right? The energy crisis challenges us to find new innovative solutions, and thorium is one of those things on the table. But it's not the only one. There's also fission research, advanced renewables, and better batteries. But thorium is especially interesting because it's a twist on technology we already have. Before we get ahead of ourselves, let's back up and introduce the superelement. What exactly is thorium, and why do some people call it nuclear energy's silver bullet? To answer that, we need to get into the basics of thorium as an element and fuel. Thorium is a natural chemical element. If you remember the periodic table in school, it was the number 90 with the symbol Th. It was discovered way back in 1828 by a Swedish chemist who named it after Thor. Pretty cool name origin, right? This element is silvery and shiny when pure, slightly radioactive, and it's actually been around us in everyday life. For example, thorium oxide was actually used in old-fashioned gas lamp mantles and those little mesh bags in camping lanterns because it slightly glowed when heated. Thorium oxide has one of the highest melting points of any oxide, around 33,000 degrees Celsius, which hints about how robust it is. In the Earth's crust, thorium is quite abundant. It's actually 3 to 4 times more abundant than uranium. Think about that. Uranium is what runs nuclear power plants today, but thorium is just kind of laying around. It's often treated as waste from mining other materials. There are millions of tons of thorium in known reserves around the world. To give a concrete example, one source estimates that the United States has enough thorium to power the country for over 1,000 years. We're not about to run out of thorium anytime soon. Abundance is great, but how do we use thorium to make energy? Thorium is not like uranium in one crucial way. The type of uranium that fuels reactors is fissile, meaning it can sustain a nuclear reaction chain by itself. Thorium's only natural occurring isotope is fertile, not fissile. In plain language, you can't just put a lump of thorium in a reactor and expect it to split atoms or create energy. Thorium on its own can't create a fire, but with a little push, it can fuel a fire. Here's how it works. When thorium-232 gets hit by a neutron, it absorbs that neutron and becomes thorium-233. Thorium-233 is unstable and decays really fast into an element called protactinium-233. Protactinium then decays over a month and turns into uranium-233. And uranium-233 is fissile. It can create a reaction. So thorium is like a seed that can be transformed into a potent fuel. Uranium-233 can undergo fission, and more importantly, create a lot of energy. In theory, if designed right, a reactor using thorium can regenerate fuel. This is called a breeder reactor, one that breeds its own fissile fuel. That was a bit technical, but let's think about it as an analogy. Thorium is like a caterpillar that needs to turn into a butterfly before it can fly. You need a neutron to spark to start the process. Once it gets going, thorium can keep turning into uranium-233. Essentially, thorium is a fuel that has to be made on the fly in the reactor. Because of this, any thorium-based reactor needs a starter. This starter could be enriched uranium, plutonium, or already made uranium-233. It's like a sourdough bread starter. You need a little bit of active stuff to get the whole thing going. Thorium won't react on its own because it doesn't create enough neutrons by itself. On the upside, it means thorium-based reactors are inherently self-regulating to a degree. If there's not an official material around, the reaction can't run away. But the downside is clear. You can't start a pure thorium reactor with just thorium. Now, what makes thorium so attractive to our current nuclear stable? Uranium. It turns out there's a bunch of potential advantages. Abundance. We already mentioned it, but thorium is 3 to 4 times more common in Earth's crust than uranium. It's energy dense. Thorium has a higher energy density than uranium. Perhaps the biggest selling point, thorium reactors are expected to produce way less long-lived waste than uranium reactors. So why didn't thorium take off when it had the chance? In the 1960s, American scientists at the Oak Ridge National Lab actually built a working thorium reactor. It was called the molten salt reactor experiment, and it ran safely and smoothly for several years, but it was shelved because thorium didn't make plutonium. And back then, nuclear energy was deeply tied to nuclear weapons. Uranium and plutonium had military value. Thorium didn't. So it lost the funding race. Plus, uranium reactors were already being rolled out. Nobody wanted to overhaul the system for a better idea that wasn't immediately useful for bombs. But here's where things get interesting. Thorium never really disappeared. It just waited. Fast forward to now, where the world is desperate for stable, clean energy, thorium's appeal is being rediscovered. Countries like India, who have massive thorium reserves, have had thorium in their long-term energy plan for decades. And in 2021, China quietly tested thorium-powered reactors in the desert. It's small, but it's real, and it could scale. Startups in Canada, Europe, and the US are racing to bring thorium reactors online. The goal? Reactors that produce less waste, can't melt down, and even use old nuclear material as fuel. Now let's simplify how a thorium reactor works, especially the molten salt kind that gets the most attention. Instead of using solid uranium rods like a traditional plant, a molten salt reactor dissolves thorium in a fissile material in a hot liquid salt. This material flows through the core, where nuclear reactors generate heat, which then can be turned into electricity. Here's the kicker. If something goes wrong, the reactor has a built-in freeze plug at the bottom. If it overheats, the plug melts, the fluid drains into a storage tank, shutting down the reaction without any human intervention. No meltdown, no steam explosion. And since the fuel is already a liquid, it doesn't need high pressure to operate. That means less moving parts, less stress on the system, and less risk overall. Today, thorium isn't just a science experiment. It's in the early stages of becoming a commercial reality. China plans to scale up its current molten salt reactors if the tests go well. India is building reactors that'll slowly shift to thorium over the coming decade. And smaller companies are developing microreactors that could bring power to remote areas. It's not a fast race, but it's a deliberate one. Thorium isn't here to replace renewables or fusion. A clean and reliable energy source that doesn't rely on weather or an exotic material. So is thorium the miracle energy source that we've all been waiting for? Maybe. It's not without challenges though. It needs more testing, new infrastructure, and more regulatory approvals. But the science is solid, and the world is running out of easy answers. Thorium offers something rare. A second chance to do nuclear energy better. If we're serious about fighting climate change and powering a growing planet, we can't afford to overlook it again. Thanks for sticking with me to the end. If this got you curious, don't stop the conversation here. Drop your thoughts below. And if you want to see more fun facts or science deep dives, hit the subscribe button. Thorium's story isn't over. It's just the beginning.